सभी को नमस्कार। आज का जो हमारा टॉपिक है जीरोस ऑफ ए पॉलिनोमियल। Before I start this topic, let's recapitulate what we have studied in class 9. So I want to discuss the topic first, value of a polynomial px at x equal to k. Let px be any polynomial in variable x and k be any real number. Then what do you mean by the value of the polynomial px at x equal to k? Let us take an example of a polynomial in x. Let px equal to x square minus 5x plus 6. Now value of px at x equal to 1, say. So I need to find out the value of this polynomial px equal to x square minus 5x plus 6 at x equals to 1. Then what will I do? In that expression, I will replace x by 1. So p1, instead of x I will write 1. So 1 square minus 5, 1 plus 6, that is 1 square is 1, 5 into 5 plus 6, adding similar sign, 6 plus 1, 7, 7 minus 5, it comes out to be 2. So value of px at x equal to 1 comes out to be 2. Let's find out value of px at x equal to 2. So here we will replace x by 2. So 2 square minus 5, instead of x I will write 2 plus 6. So that will be 4 square minus 5 to the 10 plus 6. Sorry, 4. 4 plus 6 is 10. 10 minus 10 comes out to be 0. Now let's find out value of px at one more value at x equals to 3. So it will be denoted by 3. So wherever x in that expression, we will replace it by 3. So 3 square minus 5, x is replaced by 3 plus 6. 3 3s are 9 minus 15 plus 6, 9 plus 6, similar sign added, 15 minus 15 equals to 0. So what we have seen, the value of this polynomial px which is equal to x square minus 5x plus 6 at x equal to 1, its value comes out to be 2. But for x equal to 2 and for x equal to 3, the value of this polynomial reduces to 0. So p2 also comes out to 0 and p3 also comes out to 0. So those values of x for which the polynomial reduces to 0 are said to be zeros of this polynomial. So for x equal to 2 and x equal to 3, that polynomial px get reduces to 0. So x equal to 2 and x equal to 3 are the two zeros of this polynomial. Since it is a polynomial of degree 2, that is quadratic polynomial, so degree 2 will tell about the number of zeros of this polynomial. Since it has degree 2, so this polynomial will have at most two real zeros that we have already found, that is x equal to 2 and x equal to 3. So the degree of the polynomial determines the number of real zeros, number of maximum real zeros it could have. So since it is a quadratic polynomial, so it will have maximum two real zeros, and that we have already find out, that is 2 and 3. So that we want to say the value of a polynomial px at x equal to k is actually denoted by pk, and replace x by k in the expression of px, you will get the value of the polynomial pk. So from here we have come to the definition of zeros of a polynomial. That means those values of x for which the polynomial px reduces to 0, such values of px are said to be the zeros of this polynomial. So definition of zeros of the polynomial is that those values of x for which px reduces to 0 are said to be zeros of px, that is zeros of polynomial px. Or you can simply say that a real number k is said to be 0 of px if pk equals to 0. That is, when x is replaced by pk, so that the value of px at x equal to k comes out to be 0, then k is said to be one of the 0 of px. Now, how to find the zeros of the px? For example, we take, let px is equals to x square minus 10x minus 24. To find its zeros, we mean to say those values of x for which this polynomial get reduces to 0, we will write it as px equal to 0. We will solve this equation and find out those values of x which satisfies this equation. So x square minus 10x minus 24 equals to 0. In factorization of quadratic polynomial, the video which I have already shared. So if you go through this video, you can able to factorize this polynomial. So that comes out to be x minus 12 x plus 2 equals to 0. So either x minus 12 equals to 0 or x plus 2 equals to 0. So x equal to 12 or x equals to minus 2. So 12 and minus 2 are the two real zeros of this polynomial, and these two values satisfies this equation. So you can verify it also by replacing x by 12 in that expression. So this is about the zeros of the polynomial. So basic thing about the zeros of the polynomial is that the degree of the polynomial determines the zeros of the polynomial. So for a linear polynomial, whose degree is 1, it have only 1 zeros. For quadratic polynomial whose degree is 2, will have at most 2 real zeros. Similarly, cubic polynomial will have 3 real zeros. And what about constant polynomial? Constant polynomial whose degree is 0, it includes all real numbers, and we know that constant polynomial has been categorized in two forms. One is non-zero constant polynomial and second one is zero polynomial. So zero polynomial include the real number 0 and non-zero polynomial excluding the 0, all real number excluding 0. So how many zeros a non-zero constant polynomial have? So if we see that, take an example of non-zero constant polynomial, let's 7. We can write 7 as 7x raised to the power 0. So even if we replace x with any real number, I mean to say any real number. So if x is replaced by any real number, then as per the law of exponent, if any real number is raised to the power 0, the result comes out to be 1. So 7 1 just 7. So there is no real number exists for x for which the polynomial, that non-zero constant polynomial, reduces to 0. It always comes out to be 7. So it will never and ever be 0 for any real number x. So non-zero constant polynomial have no zeros. Remember, non-zero constant polynomial, that means any real number, integer, whole number excluding 0, any rational number, any irrational number excluding 0 will have no zeros. Now next, if we come to the zero polynomial, which is 0, real number 0, then we can write 0 as 0 dot x raised to the power 0. Here if we replace x with any real number, say r, where r may be any whole number, any real number when raised to the power 0, it comes out to be 1, and 0 multiplied by 1 is 0. That means if x is replaced by any real number, then that x is replaced by any real number, then this 0 polynomial get reduced to 0. So its zeros are all real numbers. So these are the basic things which you must know, and that's all from my side. Thank you.